Hi, we're working on a project with Andrew Burgess in Birch Grove. And as part of the project, which is the project is a two-story existing building. And what we're doing is we're adding a two-story extension at the rear. And also we're removing some walls in the existing part of the building at the front of the house. So basically what we're doing is this is in Bluebeam Revu, and as part of so this is the existing ground floor. And as you can see, there's some walls which are load-bearing, including this middle wall, which is what we're going to focus on. So this middle wall is an existing brick wall. It's an existing 230 brick wall with a fireplace on both sides. So this is the ground floor of the proposal, and this is the first floor of the proposal. So you can see this is the part of the house that we're focusing on. You can see that here's the existing line of the chimney. There's 230 brick above on the first floor. There's existing 230 brickwork fireplace on the ground floor. And we're proposing to remove that fireplace on the ground floor. So on the ground floor, we have none of that fireplace exists anymore. So we're removing it. And on the first floor, we're keeping the brickwork. It's a timber frame first floor. The timbers span from front to back, so span onto this wall. And if we go back to the ground floor and we just compare the existing to the new, I've just overlaid the existing on the new. We can see that this red is where the existing brickwork is on the ground floor that we're removing. So all of that will be removed. So clearly what we need here is and I'm just going to show this on the first floor. We need a beam that will span from here, from side to side. I'll just make that thicker so that we can actually see it. So that's effectively the beam that we want to engineer today. Now I'm going to do it in Bluebeam Revu and show you how the documents will work, how we'll do the documents. I'm going to start a new PDF template using our double-sized A4 sheet. So it's twice as long as a typical A4 sheet and the same width. So we'll start with the title block. Just going to plug that into there. So we're using a tool set called Cantilever Calculations. And basically you can progress through these to build your preliminary sketches. So we'll start with a general summary. And as we said, this is going to be a existing wall removal with a single level over. Timber framed floor and 230 brick over. So that's kind of just a basic summary. I'm going to add our floor summary. So this is kind of standard. It's a timber frame floor with plasterboard 0.8. See our loads module for how we calculate that. Live load, single residence 1.5. And probably what I'm going to add here as well is 230 brick over. So that equals 4.4 kilonewtons per meter times the height. So I'm going to call this, it's actually on the first floor, so I'm going to call this first floor beam. And I'm going to start building my loads. I'm going to start with a picture. So I'm just going to copy this. Through into here. And I don't mind it. That doesn't fit, that's fine. Draw a line, which is where the beam will be. And we'll call that beam 1B1. So when we reveal our comments, you can see that that's called 1B1 in the comments. Now, because I brought this into scale, I can scale it. So what I'll do now is start building our span. So I'll start with the general span. I'll just put it down here because I think we'll be adding lots of loads. I'm going to measure the width of the building. Set the scale under 100. I like setting the precision to 1. And we can see there that the span is about 5.5 meters. So I'm going to change the span to 5,500. And again, going to measure, because what I want to know here is what the tributary width is. And the tributary width is basically 9 meters. So it means our tributary width is going to be roughly 4,500. So we'll start with a standard UDL, and I'm going to call this UDL number 01. And this UDL, while I'm here, I'm just going to add my reactions because I want to know what the reactions will be. And they populate, but I'm going to change that later once we do the calculations. The reason I do that is just so I have space I know what the space is. We can apply a left moment and right moment, but for our purposes at the moment, the beam will be simply supported with no fixed moments at the end. So we're going to delete those for the time being. So in terms of the UDL, here's where you add the UDL notes. And The UDL01 is going to be from the floor, and that's going to be, as we said, that's going to be a KPA of 0.5 and a live load of 1.5. Now, when you think about the project, you've got to think about, when you think about the structure or the building itself, that's not the only load that's on this beam, of course. So there's a couple of other loads. I'm going to start with the simple one, and that is that the UDL from the roof. It's a metal deck roof. I'm going to call this UDL01. Sorry, 02. I'm going to add another UDL notes, which is 02. And that's, I'm going to call that and that's going to be from the roof. And that's going to be, it's metal deck roof, so that's 0.4, and the live load is 0.25. And I'm going to go back up to the summary and just add that into my notes here, because that's an important part of the loading criteria. So, timber framed roof, 0.4 KPA, and I'm going to add the live load into this as well, into this same statement. So that's the load from the roof. Now, of course, I've got another UDL, and that is the brickwork. So I'll add that as a third UDL. And I'm going to say that it's from the brick wall. And that, of course, has a live load of 0, so 0.0. And as I said, it's 4.4 kilonewtons per meter times the height. So that's 4.4 times 3.0. That's the height of the wall. And that equals as a KPA, as a kilonewtons. So this is important. It's a kilonewtons per meter. So 4.4 times 3 equals 13.2, and that's important to remember that that's a kilonewtons per meter, not a KPA. When you come and add that. Now let's look at this floor plan again, because we haven't captured everything yet. And the thing is, what else is loading up this beam? And the thing that's probably quite easy to miss is the fact that this brickwork, this wall is a brick wall, and this wall is a brick wall, and they both are on steel beams, and they span onto this beam. So we have to capture that load as well. So what I'm going to do is I'm going to measure the distance away. So it's 1.6, so say 1.7 kilonewtons, meters, or 1,600 meters away from the edge. So now we have to go back to, just close that. Now we have to add this. So we're going to add this as a point load. And I'm going to call it point load 01. And as I said, it's a distance, so we'll use the dimension. It's a distance of 1.7. And we'll just make that fit to that dimension. So we'll go down to our notes. Just zoom out here a bit so we have a bigger idea. And we'll add a point load to our notes. And that's PO, defaults to PO1. And we're going to say that that is from the brick wall 2. And it is, so again, no live load. It's 1700, and we've got to calculate the dead load. So that's, as I say, it's a 230 wall, so that's 2.2 times 3 times 4.5, and that'll come in as a kilonewton. So it's 2.2 times 3 times 4.5 equals 3.3. So that's 3.3 kilonewtons that's landing on the wall. So that's 2.2 is the weight times the height times the length. That's half of 9. Gives us the, there's no harm in annotating this. .3 kilonewtons. So that's the point load, PO1. Now what we want to do is talk about the deflection criteria. And what we also want to do is talk here about the procedure that we're going to use. I'm going to start a new page here. The procedure that we're going to use to determine what the deflection criteria is. So as I said, I'm going to start a new document. And we'll call this page 2. Again, I'll just default the title block. So, and what I want to do here is I want to bring across what effectively is our deflection criteria. And this procedure, we'll go to document number 3, and we'll paste this in here. This is a procedure which describes how we're going to install the beam. And what it is it effectively says that we're going to pre-deflect the beam by forcing wedges or Fox wedges in between the new steel beam and the brickwork in order to pre-deflect the beam. So that's an important consideration because that will determine what our governing deflection criteria is. And the governing deflection criteria in this case is that we say it's somewhere between 500 and 750 if we want to pre-deflect the beam. And that'll probably become the governing criteria. And I'm just going to write a little description to say to pre-deflect the beam with Fox wedges with span on 500 to span on 750 as the deflection criteria. For the steel beam. Yep. So now what I'm going to do is I think I'm ready to engineer the beam. So we can go to microstrand or space gas or ETABS, but Radial actually has its own simple support program. So we'll go to that program to engineer the beam itself. And then what we'll do is then we'll bring those calculations back into the program. So what we want to do is we want to say we basically want to, and I might just draw a horizontal line in here just to section this off. And the deflection criteria here will be, in actual fact, we've done this calculation already, and it ends up being a 410 UB. So we'll write that in there. We won't give a weight for the time being because this is just preliminary, and once we come back, we'll do that. And then we double check it, and we say it's okay. We use another horizontal line, and I usually give this a bit more just to emphasize it a bit. We'll beef that up to 5, and that will define the end of our beam. So what I want to do now is I want to link prefer to use the icon, and I'll link the radial simple support to this program. And then I also want to go back and set the reactions to what they are. They're roughly the same for each, although slightly different. They're roughly the same for each. I'm going to go 58 kilonewtons and 23 kilonewtons. So again, 58 and 23.